Okay, let's turn to page 16 in your book, and we're going to talk about how the atmosphere is organized. So scientists divide Earth's atmosphere into 4 main layers. And these layers are actually classified according to changes in temperature. So these layers include the troposphere, which is the layer that we're currently in right now, the stratosphere, the mesosphere, and the thermosphere. Okay, so let's take a look at this diagram that talks about the classification of the layers of the atmosphere. Okay, so in this diagram, you can see that on the y-axis, it's telling you the altitude of the layers, so the elevation in kilometers, but it's not organized by the elevation or the altitude. You just have to think that, okay, it's the atmosphere. It's wrapped around a 3D round object, the Earth. Okay, and when you talk about layering, it's going to be piled up on one on top of the other. So of course, there's going to be a difference in the elevation. But how they're really organized in terms of where one layer begins and where one layer ends is the temperature, and you can see that on your x-axis. So if you take a look at the troposphere, which is where the weather occurs and where we live, okay, you can see it's starting off here on this chart at 0 degrees Celsius, and we can see that as the altitude increases, that the temperature decreases. But you see that there's a swing in the temperature and it starts to increase again. And as that temperature swing occurs, then that is the beginning of the next layer of the atmosphere, which is the stratosphere. If you take a look at where the next temperature swing occurs, that's where the next layer of the atmosphere starts, which is the mesosphere. So we go from -3 degrees Celsius all the way to -93 degrees Celsius, very cold. And again, you'll see there's another temperature swing, and the thermosphere, it's going all the way up to 1,727 degrees Celsius. So wherever you see a big temperature swing going from hot to cold or vice versa, that's where you'll see the boundaries of the different layers of the atmosphere because they're organized by their temperature. So let's go ahead and talk about these different layers of the atmosphere. We're going to first talk about the troposphere, which is on page 18. So turn your books to page 18. And the troposphere is the layer where weather occurs. Now, we've talked about weather already in this unit. So as a reminder, we know that weather is the condition of Earth's atmosphere at a particular time and place. And this occurs in the troposphere, which is where we live right now. Okay, so this is the shallowest layer. And it contains almost all of the mass of the atmosphere. So that means it contains a lot of water vapor and particles that we talked about that were included in the atmosphere. And for every 1 kilometer increase in altitude, so every kilometer you go up in this layer, the air is getting 6.5 degrees colder, 6.5 degrees Celsius colder for every kilometer you increase in altitude. The second layer is called the stratosphere. And the stratosphere is another important layer because it contains the ozone layer. And how many oxygen molecules makes up ozone? 3. Remember, O3 equals ozone. Now, the stratosphere has several different parts to it, and the lower stratosphere is cooler than the upper stratosphere because there's a middle portion of the stratosphere that contains a layer of air where there is much more ozone than in the rest of the atmosphere. And that is what is called your ozone layer. And the ozone absorbs the energy from the sun, like the ultraviolet radiation from the sun. And that energy is converted to heat and it warms the air. And the ozone layer is important because it protects Earth's living things from dangerous UV radiation from the sun. So let's find a spot on your paper where you could sketch. Okay. So let's put our boundaries here of the stratosphere. Okay. And then we're going to put this little layer in the middle here. Okay, and this is going to represent our ozone layer. Okay, now what happens is the ozone layer. Let's draw our sun up here. You know, the sun's rays are coming in through the atmosphere. And those ultraviolet rays can come down, they can bounce off, or sometimes they're going to be absorbed. And you're going to, sometimes you'll see, oh, the heat is radiating up into this upper stratosphere. So we'll put in parentheses that's showing you how heat radiates. So in the upper part of the stratosphere, that's going to be much hotter. But because the lower stratosphere is protected by the ozone layer, which is absorbing the ultraviolet radiation, then this layer is going to be much cooler. Okay, let's go on to the next section, which is the mesosphere. This is on page 20. So the mesosphere is the layer of the atmosphere that protects Earth's surface from being hit by most meteoroids. And meteoroids are chunks of stone and metal from space. Okay, so those are chunks of stone and metal from space. So how does it keep it from hitting Earth's surface? Well, the mesosphere, it's a very cold layer of the atmosphere. And the gas molecules are spread apart, and that's why it can't keep any heat. Okay, so because it's so cold, those gas molecules are all spread apart, what happens is that these meteoroids are used to falling through a vacuum, space, right? There's just nothing to it. There's no particles out in space. And so whenever they get into the atmosphere and into the mesosphere, when they bump up against those gas molecules, they start to burn up because of friction. So as the meteoroids bump into the gas molecules, it causes friction and it makes those meteoroids burn up instead of hitting Earth's surface. For the most part, some do happen to hit Earth. So I thought this chart might be interesting for you because I know some kids had questions about, well, what's the difference between all these space rocks? So this is a good visual for you. Here's our meteoroid, which is a space rock. It says it's bigger than a dust grain, but smaller than an asteroid. If it strikes Earth, okay, so if part of that is not completely burn up and it does hit Earth, then it turns into what's called a meteorite. So that's what it will be referred to as, a meteorite. Okay, now a meteor, that's a streak of light seen when that space rock enters the atmosphere and starts to burn up. You might see it and call it a falling star or a shooting star. And so if you see that, that's that meteoroid that's burning up. And at that point, when it's on fire and burning up, you call it a meteor. And of course, if that meteor doesn't entirely burn up, or there's a little piece of that meteoroid that gets through, when it hits Earth or lands on Earth, then it is called a meteorite. Now, if we think about something that's bigger than a meteoroid, you could talk about an asteroid. And that's a rock in orbit that's generally between Mars and Jupiter. But sometimes asteroids can get bounced towards Earth, but not very frequently. And then you could also have comets, and that's a chunk of ice and rock that comes from the outer solar system, and it usually has some type of tail associated with it, as illustrated in this picture. So hopefully that diagram helps you understand the different types of space rocks that you might hear about. Okay, the next and the last layer of the atmosphere is the thermosphere. And this is on page 20 of your book as well. So the thermosphere is the outermost layer of Earth's atmosphere. Okay, and the thermosphere extends from 80 kilometers above Earth's surface outward into space. So it has no outer limit and it just gradually blends in with outer space. And because there's just really no limit to the outer part of this layer of the atmosphere, that's why those meteoroids don't burn up in the thermosphere, because this still has some of that pressure of being a vacuum because it's so close to outer space. But whenever it does fall into the mesosphere, then it hits those other gas particles, and because of the friction will cause those meteoroids to burn up. Okay, but because the thermosphere is so close to outer space, that's why it doesn't happen in this layer, just in the mesosphere. Now, the word thermo, if you think about this prefix on this layer, means heat. So if you think of thermometer or thermostat, all of those things are related to heat. And even though the air is very thin in the thermosphere, it is very hot because the sunlight strikes the thermosphere first, because it's the outermost layer, the farthest away from Earth, closest to the sun in outer space. And nitrogen and oxygen molecules convert this energy into heat. But the air is not very warm, so how would it feel to you? Not warm at all. Temperature-wise, it looks like it's hot, but how do you perceive that? As coldness. And why is that? Well, because the air is so thin that the gas molecules will never bump into each other to actually make it feel warm. Okay, so we know that the temp is hot and this layer feels, okay, how does it feel? Cold. Okay, and that's because the air is so thin, the gas molecules never bump into each other to really make it feel warm. But the temperature, it's going to register as very hot, up to 1800 degrees Celsius. Now the thermosphere is divided into two layers. So the bottom layer is called the ionosphere. Okay, and energy from the sun causes gas molecules to become electrically charged. And that's called ions. Now you have radio waves that bounce off ions in the ionosphere and then back to Earth's surface. We talked about that with our electromagnetic spectrum. A radio wave is part of the electromagnetic spectrum. So when you want to talk about how do you get a radio signal or a TV signal or even cell phone service, they're bouncing off the ions in this layer of the thermosphere, which is the bottom part of it, called the ionosphere. There's also something that's really beautiful called the Northern Lights. And on page 21 in your book, you can see a picture of the Northern Lights. And they're caused by particles from the sun that enter the ionosphere near the poles. So these particles strike atoms in the ionosphere and cause them to glow. And the last part of the thermosphere is called the exosphere. And the exosphere is the outer portion of the thermosphere. It's really easy to remember because exo means outer. And this part of that layer extends into outer space. You can also think of exo as exit because this is the very last part of the Earth's atmosphere. And outside of this layer means you're out into space and outside of the atmosphere for the planet Earth. Okay, so that wraps up all of our guided notes for the layers of the atmosphere. If you need to rewind any of this, feel free to do so. And thank you for listening. There's also another layers of the atmosphere wrap that you can listen to if you have time.